As manufacturing world,
qualified engineers and technicians grows. In order to assist in satisfying this demand, the Systems Division of Denford Machine Tools Limited have developed a wide variety of computer-integrated and flexible manufacturing systems, CIM and FM. These range from basic machining cells through to advanced automated factory layouts. The CIM creates a fully integrated computer-controlled manufacturing system, which follows the production process from raw material stock holding through material transfer, manufacturing, parts recognition, inspection, to finished parts storage. As with the company's previous developments in the field of automated manufacturing, the CIM system is modular by design and can be enhanced stage by stage to suit the customer's requirements. To understand fully the nature of the Denford modular concept for computer-integrated manufacturing, it's necessary to examine each element in isolation. The Automatic Storage and Retrieval System, ASRS, is comprised of two parallel pallet storage racks, each containing 35 pallet locations, vertical and horizontal. The pallets are moved to their designated position by means of a gantry loading system. The ASRS has been based upon the systems most widely used in industry and represents the warehousing facilities of the manufacturing process. On a signal from the host computer, the robot collects a pallet from the stores and places this on the indexable conveying system. Material transfer within the CIM is carried out by an indexable conveying system, the positioning of which is governed by a series of gates and electronic microswitches. Once the pallet has arrived at the correct position adjacent to the CNC lathe, the computer gives the signal to the Orbit robot to load the billet into the machine. For this CIM, the CNC lathe is the Cyclone slant bed lathe, fitted with Denford's latest control system. Hydraulic chuck, 8-station heavy-duty rotary tool post, and pneumatic sliding guard. The Cyclone is designed and built to the highest specification, incorporating Denford's latest control package, which emulates the industry-standard FANUC programming system with the added benefits of 3D color toolpath graphics and servo drives. The machine's other industrial features include rapid traverse rates of 5 meters per minute, constant surface speed control, and variable spindle speeds up to 5,000 RPM, generated from the 3 horsepower DC spindle motor. On completion of the turning operation, the partly machined component is removed by the robot and transferred to the CNC machining center. Once again, Denford's latest control system is incorporated into the CIM on the Triac VMC vertical machining center. The Triac VMC is a floor-standing 3-axis CNC machining center fitted with a hydraulic vise for work holding, and a 6-station automatic tool changer. The machine boasts rapid traverse rates of 5 meters per minute, variable spindle speeds of up to 4,000 RPM, full 3D color toolpath graphics, tool radius and tool length compensation. In keeping with the modular nature of the system, both the Triac VMC and the Cyclone can be removed from the CIM
in order to teach the principles of industrial milling and turning in greater depth. On completion of the final machining operation, the finished component is removed from the TRIAC VMC by the robot and placed back on the conveying system to be transferred to the next element of the CIM, namely inspection. Inspection is a vital element of any industrial process. It is used to detect components which have been incorrectly manufactured, assembled, or have incorrect orientations for further processing. In this CIM, two types of inspection are illustrated: parts recognition and in-depth statistical calibration. The parts recognition inspection is carried out by using a low-cost intelligent camera, which is set up to identify and measure each component as it stops under the lens. This 100% piece-by-piece inspection can be performed at any stage of the production process and can therefore alleviate costly wastage rates. Once this has been carried out, the pallet is transferred to the ASRS. It's now possible either to store the finished components to their designated bays or to transfer the pallet to the second inspection station. The in-depth statistical calibration inspection is carried out by a CNC 3D coordinate measuring machine, a CMM. The unit incorporates a granite surface plate base with granite slideways and strips and air bearings on all three axes. It can be supplied with a complete set of measuring probes and is capable of full 3D geometric tolerance calibration on circle, plane, point, line, cone, cylinder and sphere measuring routines to an accuracy of 0.002 millimeters. Once the finished component is placed on the inspection plate, it's possible to carry out as brief or as in-depth an inspection routine as is deemed necessary. The data obtained by the inspection process is then transferred to the supervisory computer. The information which the supervisory software receives from the coordinate measuring machine will determine the final destination of the finished component. Correct or undersized parts will be placed in the appropriate section in the storage and retrieval system, whereas oversized parts will be returned to the raw material stores for remachining. Because the system is totally closed loop, it's possible to incorporate an option to automatically transfer inspection data directly to the controls of the machines, where tool offsets can be amended to correct any undersize or oversize machining which may be affecting the finished component. The production cycle is now complete. However, the interaction of these various manufacturing elements is extremely complex and can only be operated efficiently if it's controlled correctly. The responsibility of this phase of the CIM system rests with the cell controllers and the supervisory CIM software. The design of this element of the CIM has been based on a three-level hierarchy, from the machine tools on the shop floor at the lowest level, through the cell controllers at the intermediate level, to the host computer at the head of the hierarchy. This configuration has been chosen as it allows the most effective delegation of responsibilities from the top down and guarantees the correct feedback of relevant information from the bottom up. The role of the host computer is to supervise the CIM. It dispatches instructions to the cell controllers to initiate the individual manufacturing processes and receives information back from them on the status of the system. The host is composed of a number of software modules covering design and analysis of the shop floor layout, process planning, and real-time scheduling. The cell controllers are device drivers responsible for the direct control of the various machines within the CIM. Engineering students throughout the world need not only a basic knowledge of the theoretical side of automated manufacturing, they also need sound, practical, hands-on experience of the latest technology. With this in mind, the Denford System Division have designed a CIM which is flexible, modular, expandable, low cost, and one which can be interfaced with a wide range of machine tools and equipment from other manufacturers. Advances being made by Denford in the field of computer-integrated manufacturing, together with the company's basic philosophy of total compatibility, means that existing and potential customers can look forward to a future of continuous technological advances with Denford.